Okay, here we need to simplify three different numbers being raised to rational powers, fractional powers in this case. In the case of B and C, fractional negative powers. So we need to simplify 27 to the power of 4 over 3, 16 to the power of minus 3 over 4, and 125 over 64 to the power of minus 2 over 3. So we'll start with A, 27 to the 4 over 3. Now what this means is the denominator of the fraction, you take that root, and then the numerator of the fraction, you just apply that as you would normally. So it's basically the cube root of 27. That's the over 3 dealt with. And then if we raise the answer of that to the power 4. Now you could have done that the other way around. So you could raise 27 to the power 4 and then take the cube root of the answer. The reason why that's not a good idea is because you're going to get a giant number and have to cube root a giant number. It's better to go small and then big most of the time because it's much easier numbers to deal with. So the cube root of 27 is 3. So this bit in the bracket is 3. And then we need to raise that to the power 4. Well, 3 to the power 4 is 3 times 3 times 3 times 3. So it's 3, 9, 27, 81. 81. Okay, 16 to the power minus 3/4. So you've got three things going on here. You've got a negative power, which means reciprocal. You've got a denominator, which means that root. And then you've got a numerator power as well. So we'll start with the negative bit. So 16 to the minus 3/4 is the same as the reciprocal of 16, which is 1 over 16 to the power 3/4. So that's the negative bit dealt with. So then we can, because if you've got a fraction like this, the rule can be to do the same thing to the numerator and the denominator. So I can do 1 to the power 3/4 over 16 to the power of 3/4. Well, 1 to the power of 3/4 will just be 1. 1 to any power is just 1. So 16 to the power 3/4. Remember, we need to take the root, the nth root, as in n being the denominator, and then raise it to the power of the numerator. So it's going to be 1 over, well, it's the 4th root of 16, and then we cube the result. So the 4th root of 16, well, you're saying what number times itself again equals 16, and that number is 2. So the 4th root of 16 is 2, because 2 to the 4 equals 16. So you got 2 times 2, so 2 squared is 4, times 2 again is 8, times 2 again is 16. 2 to the 4 is 16, so the 4th root of 16 is 2. So this is now 2 cubed. Then we just need to do 2 times 2 times 2, which is 8. Okay, so part C, this is really where taking this kind of long approach is really useful. So if you try to use like a simple approach, as in we just do 1 over this number to the positive power, yes, it will work here, but it won't work with this. It's just not, it's not going to work. So if we use the approach, we've got 125 over 64 to the power minus 2/3. The negative bit means reciprocal. So we take the reciprocal of 125 over 64, we just flip it upside down, 64 over 125, and then we apply the positive 2/3 power. So then we do 64 to the power 2/3 divided by 125 to the power 2/3. The power of 2/3 means we take the cube root and we square the result. So we do that to both. So it equals the cube root of 64, and then we square it over the cube root of 125, and then we square it. So as I was saying, your cube, now you do need to know your cube numbers, and the best, if you're thinking, I don't know the cube root of 64, I don't know the cube root of 125, just think the other way around. Think of your cube numbers. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4, well, 4 4s are 16, times it by 4 again is 64. So 4 cubed is 64, which means that the cube root of 64 is 4. So that's the first bit. Then if we take the next number, well, 5 times 5 times 5, and 5 5s are 125, sorry, 5 5s are 25, times it by 5 again is 125. So 5 cubed is 125, which must mean that the cube root of 125 equals 5. So these numbers in here, this is now going to be 4 squared over 5 squared equals 4 squared over 5 squared. 4 squared is 16 and 5 squared is 25. So that's finished.